Hey guys, it's Eric here at Farpoint Restorations. Check this out. I wanted to show this thing off. I'm going to be doing a whole series on the different types of engines that have been built over the many years that we've been on this earth. And this is the first one I'm going to cover. This was largely responsible for the Industrial Revolution. It's the steam engine. You saw them they were operating factories, and certainly they were operating farm equipment and tractors, as well as, of course, the steam engine trains that lasted all the way up through the early parts of the 20th century. But here is the most simple, basic setup you can have. And of course, I'll go over some of this with you here as it operates. It's probably going to run out of juice eventually here, but this large piece right here that you see rolling around is called a flywheel. It is a large weighted piece of metal, and it carries the momentum of this action as the steam pushes that piston up, and then the excess steam is allowed to burn off. Momentum from that weighted flywheel allows this to continue to operate. Throttle control, the more steam we let into the piston, the faster the engine will go. And we can slow it back down again. And you can see it'll move quite fast. Now back here, this is where we are making our magic happen. This fuel source is alcohol, in this case, methyl alcohol. But it could be anything. It could be coal, could be wood, could be just about any combustible material. And then we have a pressure chamber up here. That pressure chamber is full of water, but as it boils that water, we are getting steam up in here. That steam is then routed down and around into our chamber here where it feeds the piston. This right here is our exhaust. That's where the excess steam, and in this case liquid, because this isn't exactly the finest burning machine, is operating. So let me slow it back down. And you can see it works. How much pressure it produces? Well, in this teeny weeny engine, not a lot. You can stop it fairly quickly. But there you go. Pretty incredible. Now, because most of the pivot points here, well, all of the pivot points here are external, on your steam engines, on your engines of this era, you would have had to have grease fittings on the outside. Now, the next engine I'm going to take a look at in another video here is called a hit and miss engine. It ran off of gasoline, but it didn't fire on the two-stroke or four-stroke pattern that modern engines do. It was something entirely different, and of course we'll get into that in the next video. But for this, it's amazing that these things are still used. Now, you could have more than one piston. Many of them did. If you're trying to operate a train, one piston obviously isn't going to be a really efficient way to do that. But you could have multiple cylinders, multiple pistons, and create more power. But of course that meant having a larger steam reservoir, having more fuel to heat up that steam, and having it operate as it goes. You can see it from the top down. Now this one here, the gauge was damaged in shipping, so it doesn't go up. You're supposed to max this thing out at 15 PSI. Any higher than that, and you could run into some issues with explosion. And you go too far out, it actually starts to slow down because you're bypassing. Too much of the steam is escaping before the piston can be fully inflated. So there's a sweet spot to this one. And we'll slow it down to sewing machine level there, right? So these were used in factories quite a bit. You'd have a large external power supply, a large steam engine somewhere, and that would run all the equipment to run presses and drills. And these, it's incredible. Here's a picture of one here. Belts all over the place, running all over to all the different equipment that was out there. Pretty incredible piece. So a system like this, what could you use it for today other than this size here for demonstrational purposes? Not a whole lot. But if you had one that was, say, the size of a lawnmower engine, it actually would be useful for some limited stuff, using that to grind grain down or something like that. So it still has purpose. And of course, in the use of battleships, we have replaced, or not battleships, aircraft carriers and submarines, we've replaced this portion partially. That is now nuclear fusion, and that is our pressure tank. So we're taking seawater, or I think I actually use real clean water, desalinated water, and they pressurize that, and they use that to run the engines on our aircraft carriers and on our submarines, just using the fusion instead of using oil or coal or whatever other material was available. And so it's a very cleanly operating system. Fusion occurs, we're creating a massive amount of heat, and that's how we run it. Nuclear power plants also still run on this basic principle. So even though this is a very old design overall, it is still in use. It's still in use. Well, I guess that'll do it for today. I am going to make another video here. Yeah, I'll make another video here on hit and miss, and then we'll move into two-stroke and four-stroke engines. Eventually, I will get into videos on turbines and even on solid rocket boosters. So I hope you enjoy this little series here, this kind of educational thing. I had this, I wanted to show it off and use it as a training guide for people interested in steam engines. Till next time, my friends, take care.